combine them because you need a common denominator, and these ones already do have one. So you write it as equal to, and it's all over x. Just like when you did 1/3 plus 2/3, you get 3/3. You get a common denominator for a reason. You don't get a common denominator and then like add them. What would be the point, right? If you're getting a common denominator, you're getting a common, so you just rewrite it, or else there'd be no point in getting a common denominator. So once we have a common denominator, we can do the operations of the top. So 7x plus 1 plus 5x minus 2. And then all we do is we collect like terms on the top. So 7x plus 5x is 12x. And then 1 minus 2 is negative 1 over x. And you have to say x can't equal 0, because that's the MPV for this one. How would this question change if I had a minus sign in between? There's an extra step that everyone messes up, though, if I had a minus sign in between. What would happen? Right. So if we have 7x plus 1 over x, and it said it was minus 5x minus 2, you'd have to make sure that you still have a common denominator just like this. But the last one I went 7x plus 1 minus 5x minus 2. If I did it like this, like I did the previous one, I would be wrong. Right, because I need to subtract everything behind the subtraction sign. So in this case, if I kept it like this, I'm just subtracting the 5x. I need to subtract the 5x, and I need to subtract the 2, the negative 2. So it's actually plus. So you can put it in brackets and distribute it, yeah. And so you're going to get 7x minus 5x, which is 2x, plus 3 over x. So if there's more than a monomial behind the subtraction sign, you have to remember to subtract it all, right? Now B has common denominators of x minus 3. Yeah. We're going to have to do a whole bunch of, the denominator's not the same, we have to make common denominators first, and then you still have to remember to subtract everything behind it. There's just more steps. No. Okay. So we're going to get x minus 3 in the denominator, and then on the top, we're going to get x minus 3. Now, before we actually cancel those, what do we have to do? So x can't equal 3. And then these cancel off completely, and it's a 1, because they're in brackets, right? So 1 is the answer, and x can't equal 3. Mm-hmm. I subtracted them. That's how I got the x minus 3 on the top. Like the x minus 3 on the bottom is just the common denominator, and then x minus 3 is the top. Just did operations. Okay, what's the problem with C? So, C, there's not common denominators. So what people do is they're like, if I just add 2 or subtract 2, I can make these common. They'll just be x. No. That's what I get all the time from all of you, which is wrong. In order to get a common denominator, you have to multiply. Okay? If I multiply this by negative 2, it's actually going to be negative 2x minus, or x plus 4. If I multiply this by, like, if I multiply them by 2's and negative 2's, they're not going to make them the same at all. This is an x minus 2. This is an x plus 2. They're not alike at all. So what you have to do is you actually have to multiply them by each other. So, to the numerator and the denominator. So we're going to get this one multiplied by x plus 2 over x plus 2. And this one multiplied by x minus 2 over x minus 2. Now, you will distribute the numerators. You will distribute the top and then collect like terms. But the denominators, you will keep in brackets. So on the top, you're going to get 5x plus 10 over x plus 2x minus 2 minus 3x minus 6 yeah. It will be when you actually do the math. You're going to. Yeah, as long as you don't mess it up. And then it's going to be all over x plus 2, x minus 2. And you're going to get minus 3x plus 6 because you're subtracting them. Then you collect like terms on the top. 5x minus 3x is 2x. 10 plus 6 is 16. Okay, you're going to try these two. They already have common denominators. So this one you'd get 10m minus 1 over 4m minus 3 minus 8 plus 2m. So you'd get 10m plus 2m is 12m minus 9 over 4m minus 3. Take out a 3 and you're left with 4m minus 3 over 4m minus 3. And before you cancel those off, let's say 4m minus 3 cannot equal 0. 4m cannot equal 3. M cannot equal 3 over 4. This one, you get 2x squared minus x plus 3 minus 6x minus 8 all over x minus 3x plus 1. So you get 2x squared minus 7x minus 5 over x minus 3x plus 1. Does that factor? No. If this was a plus 5, then it would factor, but it's not. So you can't. X can't equal 3 and negative 1. Oh wait, what's the problem with this one? Different denominators. To get common denominators, you multiply by something. What can I make 6 and 4 be common to? 24, some people say, but there's actually something better. 12. So I can multiply this one by 2. And this one by 3. So these denominators we'll put together as 12 and 12. The other ones we didn't FOIL together, right? But these ones we will so that they're over 12. So we're going to get 2 times 2x minus 1 over 12. You don't have to show this step, I just am. 3 times 3x plus 2 over 12. And then it equals 4x minus 2 plus 9x plus 6, because you have to distribute, all over 12. And then 4x plus 9x is 13x. Negative 2 plus 6 is positive 4 over 12. And that's it. There are no NPVs because you don't have a variable in the denominator. B, now some people might say because when I did the x plus 2 and the x minus 2, we just multiplied by each other. But we did that because x plus 2 and x minus 2 couldn't reduce at all. So what you have to do is look and see, can I maybe take out a GCF or factor my denominator so that I maybe do have a common term between them? So on the left denominator, I have 3x plus 9. I can take out a 3. And I'm left with x plus 3. Minus, on the right, I have 16x. I can take out a 4. And I'm left with x minus 3. Let's make this be plus, just for ease, before we go to a harder example. Let's pretend it's a 4x plus 12. Okay? Now, sometimes you can take a GCF out and there's nothing in common. Well, then taking the GCF out wasn't helpful. But in this case, let's say I took a GCF out, and now they have what in common? They both have an x plus 3. So I know this one has an x plus 3, and this one has an x plus 3. So at least that term is the same. Then they have a 4 and a 3. So what could I make them be common? 12. So I don't have to multiply by the x plus 3s because those already are common, right? But I can multiply this side by 4. Oh, that didn't work at all. Okay. 4. It just got mad at me and like stopped working. 4. Oh, seriously. Nope, I give up. It's not working. And then multiply this one by 3. So we're going to get 12 over 12x plus 3 minus 48x over 12x plus 3. And now we've come denominators. So we're going to get 12 minus 48x over 12x plus 3. What could I do? Take out a 12. And I'm left with 1 minus 4x over 12x plus 3. What's my NPVs? X can equal negative 3. You wouldn't be simplifying it, and then you wouldn't know you could take the 12s out. So yeah, you'd lose marks. No. Yeah. minus 48x from the top. There isn't one on the bottom. I just took a 12 out. And then the 12s cancel. I just took out a GCF. I didn't get where you were talking about, but yeah, I just took a 12 out. What's 12 divided by 12?